Good morning, students. In the last class, we have seen resolution of vectors, addition and subtraction of vectors by graphical method. Okay, in resolution of vectors, we have seen unit vectors whose magnitude is 1 and shows the direction. Next, we have seen rectangular components, horizontal component and vertical component. If a vector A of magnitude A makes an angle theta with the x-axis, then along the x-axis the component we written as AX is equal to A cos theta, and along the y direction AY is equal to A sin theta, and we given the unity vectors along x-axis as I cap, along y-axis as j cap, and along z-axis k cap. Okay, I, j, k are unit vectors. Their magnitudes are 1. Clear? And we have seen 3-dimensional vector also. Okay, that is A is equal to Ax I cap plus Ay j cap plus Az k cap, and magnitude also we have seen. Clear? Now, and their components also have shown. If alpha, beta, gamma are the angles between vector and 3 axes, then Ax is equal to A cos alpha, Ay is equal to A cos beta, and Az is equal to A cos gamma. Squaring and adding, we will get the magnitude and the angle of direction of the vector also for a 2-dimensional vector. Tan theta is equal to Ay by Ax with respect to x-axis. If they ask with respect to y-axis, then tan theta is equal to Ax by Ay. These are all we have seen in the last class. Now today we will see vector addition analytical method. Next important discussion. This we do expect for 3 marks. Explain the vector addition by analytical method. So this is 6th one. Vector addition analytical method. Vector addition analytical method. Okay, this is very simple analytical method. Take consider 2 vectors. A is a vector. This how do we write? Ax I cap plus Ay j cap. First I am taking 2 dimensional. Ax is the component along x-axis, Ay is the component along z-axis. Take another vector B. This is Bx I cap, By j cap. Clear? So already in the last class we have seen how to write the vector in 2-dimensional. Okay? That's why I am writing Ax I cap plus Ay j cap and Bx I cap plus By j cap. First we are adding 2 vectors. That too also 2-dimensional vector. We are not considering k cap. Clear means Az k cap. Now A plus B is what? Addition. Clear? A plus B is the addition. Or if we take the addition, how do we take? Let us say R will be the addition of A plus B. Okay? The sum we are representing, we are adding a vectors, we will get again vector. That we are representing with R. Now substitute these values here. Ax I cap plus ay j cap plus what is b vector? Bx I cap plus by j cap. Okay, this write like this: ax I cap plus ay j cap. Remove the brackets. Bx I cap plus by j cap. Now items in this I cap you take it common. What do you get? Ax plus bx I cap plus next j cap you take the common, then ay plus by j cap. Clear? So this is vector r. So this we can write r is equal to rx I cap plus ry j cap. Where rx is equal to what? It is ax plus bx, and then what is ry? Ry is equal to ay plus by. Clear? See this. By adding two vectors, again we got vector in terms of I cap and j cap. So ax here ax, ay, bx, by are the components along x axis and y axis. Understand? Very simple. Just we are, what did we take here? I cap vector components we added and the j cap vector components we added. By adding these two we will have a one number that we denoted with rx. This is also we denoted with ry. Clear? Now we will come to know by seeing this example. Take vector A. Let us say this is 3 I cap plus 2 j cap, and vector B. What is that? Let us say simply I cap plus 3 j cap. Okay. In this example, A and B are in the form of this vector notation. Then from A, what is Ax? Ax is equal to 3, Ay is equal to 2. What is Bx? Nothing I have given. What does it mean here? This is 1. Okay? I cap means the magnitude is here is 1. I mean this component is 1. So 1. Next by. What is that? 3. Clear? This is one way, taking directly. Or you are not interested to take direct, you can, how do you take? R is equal to A plus B. Okay, then R is equal to, what did we get here? What is that? Ax plus Bx I cap plus Ay plus By j cap. Final in the addition this. What are the Ax, Bx and Ay, By? Ax is 3, Bx is 1, I cap. What is Ay? 2. What is By? 3, j cap. 3 plus 1, 4 I cap plus 2 plus 3, 2 plus 3, 5 j cap. Now this is the final vector after addition. Clear? Suppose, take one more example. Let us say we have a vector like this, say 3i cap minus 2j cap. Clear? Next b is equal to same vector, you take I plus 3j cap. In this case, how to do? Very simple. Same, we can write components Ax for a vector A. This is in the form of Ax I cap plus Ay j cap. Then Ax, what do we write? 3 Ay. What do you write? Plus 2 or minus 2? Here plus is there, we take a plus 2. But here minus is there, we need to write minus 2. Next, Bx. What is the component here? 1. For I component is what? 1. By is equal to what? 3. Then finally, if we follow this formula, ax plus bx I cap. So 3 plus 1 I cap plus what is there? Ay by. Ay is minus 2, by is 3. It is 1. Take it. Now finally r is equal to 4 I cap plus minus 2 plus 3. 1 k cap. Instead of writing 1, you just simply write k cap. Understand? Clear? Now this is a way to do the what is the addition of vectors. And one more important point. If they ask find the magnitudes of A and B, magnitude of A and magnitude of B, if they ask, then how do you write? Already we have seen magnitude formulas under root of ax square plus a y square, and this is equal to, how do you write? bx square plus b y square. This is individual vectors, individual magnitudes. If they ask after addition, what is the resultant of, what is the magnitude of this resultant vector? I mean resultant in the sense, what was the result here? Addition of a plus b. Understand? In this case. Now this r magnitude, how do you write? Under root of rx square plus ry square. How do you get rx? By adding ax bx. How do you get ry? By adding ay by. Now this is a formulas. Already we have seen that. Then here, what is the magnitude of a? Magnitude of a. How do you write? Under root of 3 square plus 2 square. This will be under root of 9 plus 4. This is under root of 13. Similarly, magnitude of b. How do you write? Under root of bx square. What is there? Bx plus 1. So 1 square plus by square. What is there in by plus? Where 3. So 3 square is 1. Now this is under root of 1 plus 3 square, 9 root 10. This is what? Individual magnitudes. After addition, the resultant magnitude under root of 4 square plus 5 square. Then this is under root of 16 plus 25. Under root of 16 plus 25, 4, 44. No need to find the again root values. Up to here, okay. Now for this vector, what is magnitude? Okay. For this vector, magnitude of A. Then how do you write? It is minus is there. Clear? Here it is plus is there. So don't confuse. For a plus vector, it is plus. Don't think like that. Clear? See what we are considering here. Ax is what? Magnitude, a component of I. This component square here. Ay is what? Is a component of j. Component square. So then what will happen here? What is a component of ax? I mean component of I cap, that is ax is 3. 3 square. This is there plus there in the formula. Don't write minus. This plus is as it is. Understand? Next, what is there in ay? Ay is what? Already we written minus 2 whole square. So under root of 9 plus 4 root 13. Understand? In this minus is there, don't write minus here. Understand? This is plus is there, this is formula. Plus is given in the formula. Clear? Ay square is minus 2. Make it square. So we are doing square. Always we will get plus whatever the component plus or minus. Understand? In the magnitude we will get plus only. Clear? Now remaining vector I will follow here. And here this addition is done wrong. 6 plus 5 is 11. So here it is not 44. This is what? 40. 1. Understand how to do this two-dimensional vectors addition. Clear? Make a note on this. So now we'll see three-dimensional vector. Take place Az k cap, Bz k cap. So R is what? A plus B. Okay, I am writing directly. R will be, if you take the common I components, Ax plus Ay I cap. Next, Bx By J cap, and next we will get another term Az plus Bz k cap. This we will write like Rx I cap plus Ry J cap plus Rz k cap. Clear? Then what is the Rx? Ax plus Bx. Rx is equal to what? Ax plus Bx. Ry is what? Here Ax. This is By. Oh, J component Ay, not By. This is what? Ay. So Ay plus By. Next, Rz is equal to Az plus Bz. Clear? So this is the procedure to do the addition by analytical method. So if vectors is given in this form, then this procedure is valid. Clear? Now we will do subtraction. Same vectors I am taking. First we will do in two-dimensional. Then we will write in a three-dimensional equation. A is a vector Ax I cap plus Ay j cap, and B is another vector Bx I cap By j cap. Are you following? Ax, Ay are what? That are components. Ax is the component of I cap. Ay is the component of j cap. Similarly, Bx and By. Don't forget, okay? They are components. Clear? If I write 3x, what does it mean? X component is 3. If I write 4y, y component is what? 4. Clear? So like that. Now we are doing subtraction. R is equal to A minus B. Same procedure. What do we get? We will see now. Ax I cap plus Ay j cap minus Bx I cap plus By j cap. Okay? Clear? So generally what do you expect? Resultant? What do you expect? You may expect this result. Ax plus Bx I cap minus Ay By j cap. This is a common expectation for all. Okay, because by addition we have done addition. Clear? Here also we got, there we got plus. So minus is there. This you may expect minus. Let us see now whether we will get that or not. This is our expectation. This is not final equation. Our expected equation, assumed equation. Okay. Now following this procedure, then remove the bracket. Ax I cap, Ay j cap. Multiply this minus inside. Minus Bx I cap minus By j cap. The next term is what? Take it I components. In I components, take it I component. I is component, unit vector. Then Ax minus Bx I cap plus, take it j common. What do you get? Ay minus By j cap. Understand? If you multiply this j into Ay, what is there here? Plus. So plus Ay j. Next what is there? B by j is there. So minus, plus into minus, minus into j cap minus b y j cap. Nothing wrong, right, in this way. Clear? So what is expected previous before this then what before doing this, what did we expect? This expected equation, but this is wrong. Here we expected plus, but we got minus. Here we expected minus, but plus. Clear? So simply don't expect the equation without doing. So first we need to do on paper. Then this is R. So R we can write resultant vector Rx I cap plus Ry j cap. Then what is Rx? Rx is equal to Ax minus Bx, and Ry, what is this? Ay minus By. Clear? So this is the difference. I hope you find the difference between addition and subtraction. Very simple. In the final result, in a final vector, Rx represents what? Subtraction of whose subtraction? I components of two vectors. In Ry is represent what? The result subtraction of y components in two vectors. That's all. Understand? Take the same example. You will get the answer. I will explain you. Take the one example. Same vector A is equal to, let us say, I cap, the same form, I cap plus 2j cap. B is another vector. Let us say this is minus 2 I cap plus 3j cap. Clear? Again, I am not writing ax component, ay, az and ay and ax and ay. I am taking directly, and I am substituting directly in the formula. Our intention is what? Subtraction, a minus b. Clear? So now, actually, already I mentioned subtraction is not there in the vectors, but subtraction we can done by vector addition only. But general method I am following here. So now, what is the resultant vector? Ax minus bx I cap. Then R is equal to what? Ax minus bx I cap plus ay minus by j cap. What is Ax value here? First vector, A vector 1 minus what is Bx? Minus 2. This is I cap plus next Ay is what? 2 minus what is By? 3 j cap. Minus of minus plus 1 plus 2 I cap plus 2 minus 3 minus 1 j cap. So this is 3 I cap minus j cap. This is the subtraction of these two vectors. This method is called analytical method. If you take 3-dimensional vector, what do you get? What do you get in 3 dimension? If you take it for these two vectors, what do you get? A minus b. Follow the same method. Then I am writing here for 3-dimensional vector. Here it is. What do you get? Minus. Here you will get minus. This place is as this. And here in the components only subtraction we need to write. So what do you get here? Minus. This is plus is common. This is minus. This is minus. Then this Rx I cap plus this remains same. But here this will, here instead of addition symbol we need to write subtraction. Understand? Clear? This is the analytical method of subtraction, but not given. Sometimes we will expect questions on this. That's what I given. In your textbook they given only addition. Clear? For to solve the problems I have given this explanation. Please practice and make a note of this. Okay. In the last discussion we have seen addition and subtraction of analytical method, and now we shall have a new discussion that is very important. It's very important. Not only for PU, for higher education also it's very, very, very important. So the given question is, this is actually example problem 4.2. This will be expect for 5 marks or sometimes 3 marks. But this is an example problem. It is not exactly problem. It is a derivation. Very, very important derivation. What is that? Find the magnitude and direction of the resultant of two vectors A and B. This A and B I written arrow, but in textbook they given bold letters. Okay, they printed with bold letters, but writing A and B thick is difficult every time. So I written arrow above the letter, and A and B in terms of their magnitude and angle theta between them. This derivation also we call it as parallelogram law of vectors. What is that? Parallelogram law of vectors. Now we will follow the question. Clear? So what did they give? First two vectors given A and B. They are acting from the same point with certain angle. Clear? So here I am drawing. This is vector A. From whom it is acting, vector A. What is the magnitude of this vector A is A. OP is what? OP represents the vector A. And take another vector. This is also acting from O. This is vector B. What is magnitude? Simply B. Or what is the angle between them? This angle is theta. Okay? Clear? Understand? Two vectors acting from the same point. Now, the magnitude and the direction resultant of two vectors A and B in terms of their magnitudes. We need to find the resultant of these two. If we follow the vector addition, graphical method, C is equal to A plus B. That method also we call it as a triangle of vectors. See, I slide this vector to here. Already I mentioned, by sliding there is no effect. The sliding will not affect the direction magnitude. This is vector B, magnitude is B. Okay. Now by sliding, what happened? This tail of B touching head of A. Now the closing side. This is the closing side. This I am taking as R. There in graphical method we have seen, I taken C. Now I am taking R. No difference. This how do we write? A plus B. They are asking this vector magnitude. Understand? This vector magnitude. Now OP is one vector A and OQ you take it. This represents B vector, and if you draw this, in first case what did I do? I slided this vector from O to P. Instead of this, if I slide this vector to up, what will happen? See. Again, this is A. Magnitude is what? A. See, by sliding this, tail of A touching head of B. Again, closing side is what? This is remains same. A plus B or B plus A. So now we are going to find the magnitude of R. Understand? Vector A and B given in the form of vector, instead of two dimensional A xi cap, A y j cap, instead of that they given only in magnitudes. Clear? Now this is the resultant. We call it as, not sometimes. This is, instead of calling A plus B, we will call it as resultant vector. What is this? This is resultant vector R. Now we are going to find the magnitude of R. Put arrow here. All are vectors only. Clear? Now this vector making an angle alpha with OP, vector A. Clear? So to find the R value, you will come to know what is R, what is magnitude, everything you will come to know in this derivation. Till then you just follow. So to find this R, this is O, P, Q, this you take it S. Don't take it R, O, P, Q, R, because already we selected R. Okay? So for our convenience to find the R, I am extending this line. Why? You will come to know now. I am drawing one line from S. What do you get here? This extended two lines, extended OP, and this you take it, let us say M. From P to M I extended, and SM I have drawn. SM will be exactly perpendicular to PM. Am I correct? Now see the triangle OSM. OSM. What is this? It is now right angle triangle. Right angle triangle, we have a formula to find the hypotenuse. Side square plus side. Hypotenuse square is equal to side square plus side square. Now I hope you understand why we extended this line and why we draw SM to make it right angle. Now see, this line we extended and this is parallel to B. Then with the horizontal this angle remains same. Whatever the angle is there, same angle will be subtended here. Understand? And now what we got, what we have done now, we made one right angle triangle from which triangle? OSM. This is what? Right angle triangle. This is which triangle? Right angle triangle. Then how do we write? What we required? OS required. So OS square, hypotenuse square is equal to side square. OP square plus, what is this? SM square. Am I correct? Clear? Pythagoras theory. Now OS represent what? Magnitude R. This is what? Not OP, this is OM. Right? OM, SM, right. And now OS is represent what? Magnitude of vector R. So this I can write R square is equal to OM. OM is what? From here to here. But this OM, how do we write OM? Is equal to, what do you write? OP plus PM. OM is what? OP plus PM. So OP plus PM whole square plus SM square. Am I correct? If you want to put in bracket, okay, to avoid the confusion. Then this is A plus B whole square form. Then how do you write? OP square plus PM square plus 2 OP PM. To avoid confusion, I am writing brackets, so don't worry. Am I right? OP square plus PM square plus 2AB, 2OP PM SM square as this. Now we need to write these all values. What are the values? Already OM we written OP plus PM. Now write down the values. OP is what? OP represent A. Very clear. Understand? PM represents, this is PM, that we don't know, we need to calculate. Next SM, that we need to calculate. For that, I am taking this triangle. Which triangle? Triangle, right angle triangle only. That which triangle? Right angle triangle TSM. Here I am drawing here this vector. This is what? Which vector? This is PS. PS representing what? B vector whose magnitude is B. And we extended this line. This is M. And we drawn one perpendicular. SM. This perpendicular SM is a perpendicular to PM, and this angle is theta. What we required? PM we required, SM we required. Okay, this magnitude is B. We know the hypotenuse. We need adjacent side and opposite side. To find the adjacent side, which trigonometrical ratio helps? Because we know the hypotenuse. So that we need to select the trigonometrical ratio that contains hypotenuse and adjacent side. That is what? Cos theta. Cos theta is equal to what? Adjacent side, PM by PS. So this is PM by what is PS value? B. We are not right, don't write the vector, write the magnitude. Then PM is equal to what? PM is equal to B cos theta. Similarly, opposite side required. Hypotenuse and opposite side. Which trigonometrical ratio? That is sin theta. Sin theta is equal to SM by what is there? SM by P. Yes, this is equal to SM by what is PS? B. Then SM is equal to B sin theta. So to understand, I have given in the examination, these are all not required. You can write directly. Then OP is A. What we got? PM. PM is equal to what? B cos theta. Then SM is what? B sin theta. Now in this equation, R comes known now. Now R square is equal to what is OP? A square. What is PM? B cos theta whole square plus 2 as it is. What is OP? A. What is PM? B cos theta plus what is SM? B sin theta whole square. Now R square is equal to A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. Clear? Now R square. See this equation. A square common. Don't worry about A square. B square cos square theta. B square sin square theta. What is common? B square common. So this we can write A square plus. If we take it B square common in these two terms, cos square theta plus sin square theta plus 2AB cos theta. Right? Now I am writing this equation, final equation, R square. Continuation of this. A square plus B square. What is this? Cos square theta plus sin square theta. This value is 1. You know very well about this equation. Clear? In trigonometry, sin square theta plus cos square theta is equal to 1. So B square into 1, B square. Then 2AB cos theta. Then R is equal to under root of A square plus B square plus 2AB cos theta. This is the required formula. Find the magnitude and direction. First we calculated magnitude, direction of the resultant of two vectors A and B in terms of their magnitudes. A and B vector magnitudes are what? A comma A and B. Now see the formula. A square plus B square plus 2AB cos theta. This is resultant formula. Magnitude of resultant vector formula. Understand? Clear? Okay? This formula is not valid. Suppose A given like AX I cap plus AY j cap. B is equal to BX I cap plus BY j cap. If the vectors provide like this, don't use this formula. Understand? If vector provides like this 2 and B is equal to 3, theta is equal to 90. If they provide information like this, this helps. Don't confuse here. Altogether we are seeing all the formulas. So to avoid the confusion, I am explaining. If the vector provided in this case, we don't use this formula. Understand? If the vectors provided in this case magnitude form, then we will follow this formula. So this derivation is very important up to this is up to magnitude. Then another question is there. What is that? Direction. Direction means already I mentioned in the last class. In the physics, direction we can specify using angles only. R is the resultant vector. This R is the magnitude. We got the formula. What is the R? Direction with respect to A? Alpha. What is that? Alpha. And now the same triangle. What is that? From what is that? OSM, right angle triangle. We require what we require? Alpha. Okay. We know this OM value. We know the SM value. Am I correct? We know the OM value. OM is nothing but OP plus PM. All known. So we know the adjacent side and hypotenuse. Which trigonometric ratio contains both adjacent side and opposite side. That is tan alpha. Tan alpha is equal to what? SM by what is that? OM. This is equal to SM by OP plus PM. Am I correct? SM by OP plus PM. Then tan alpha is equal to what is SM value? Already we got. We calculated B sin theta by what is OP? A. What is PM? B cos theta. B cos theta. So this is the direction formula. Or if they ask alpha is equal to tan inverse of B sin theta by A plus B cos theta. This is alternate form. Understand? Alternate form of this tan alpha. Clear? So this is the question, but this we call it as parallelogram law of vectors. What is that? Parallelogram law of vectors. Already we mentioned to define the vector. Which quantity is said to be physical quantity is said to be a vector? They have magnitude and direction as well as they have to obey vector laws. One vector law is parallelogram law of vectors. Another one is triangle law of vectors. Already we have seen in a graphical method. There I did not mention addition of vectors, graphical method. Triangle will form, that is triangle law of vectors. If required, I will explain again. But now this is what parallelogram law of vectors. Why they call it as parallelogram? You see this, except this O P Q S. How it looks? Parallelogram. Now, how do you give this statement for this parallelogram law of vector? Parallelogram law of vectors statement is two vectors acting from same point so as they represent sides of the parallelogram. Am I correct or not? Two vectors acting from same point so as they represent sides of the adjacent sides of the parallelogram. Clear? And the diagonal of the parallelogram represents, this is what diagonal of the parallelogram represents the magnitude and direction of resultant vector of 2 A and B. From where? Same point. Understand? Parallelogram law states that when two vectors acting from the same point so as they act as a sides of the parallelogram, the diagonal of the parallelogram represents the resultant of two vectors, represent the magnitude and direction of the resultant vector of two vectors acting from the same point. Clear? That is the statement of this parallelogram law. Okay, we do expect to raise this question. Direct this method, find the magnitude and direction of the resultant A and B, or state and explain and this parallelogram law of vectors. So for both the question, the derivation is remains same. Up to if they ask up to magnitude, right here. Suppose if they ask magnitude and direction, follow this also. So very important. Practice many times. Right now we will make a note on this. Now this is called law of, sometimes we call it as a law of cosine. Clear? Now we will see the law of sines. What is this law of sines? Okay. This is very simple. This we don't expect for PU. This law helps to find the answers in the competitive exams in simple method. Okay. So already we taken alpha here, we taken theta here. Here I am taking another angle. This is beta. Okay. Clear? To find this sines law, I am drawing one normal like this. And from P2, this you take it M. PM is a normal to, who is normal in the sense perpendicular. Whenever we say the normal, you consider as a perpendicular, that's all. Normal to the surface means perpendicular to the surface. Understand? Normal to the plane, perpendicular to the plane. Remember, normal in the sense perpendicular. Now, I am selecting two triangles. First triangle is OS. Already we taken M here. So to avoid the confusion, what do you take here? You take N because already M selected. So this is M. Okay. In this triangle, I would like to find SM. What is the SM? Opposite side we require. So what is the angle in this triangle? Alpha. This triangle. Okay. So sin alpha is equal to, what do you write? Opposite. Yes. M. Am I correct or not? Yes. M. Okay. SM by, what is there? Hypotenuse. What is that? O. Yes. So SM by, what is OS? We taken as R. This total length. So now SM is equal to what? R sin alpha. Am I correct? In this big triangle. Now take another small triangle. In small triangle, what is there? SM already we calculated in small triangle. Am I correct? For a small triangle, from small triangle, what is that? What do we take? Triangle PSM. In PSM, what is there? SM is equal to what? B sin theta. Okay? In this SM, both are same. So we can equate these two. You can equate. How do you write? R sin alpha is equal to B sin theta. This we can write sin alpha by B is equal to sin theta by R. This you consider equation 1. Right? Now, so to take to find SM, I kept diagram this like I did not remove this, right? I did not draw. I did not clean also. So to find the SM, this portion I did not remove. Now I am removing to find another equation. And now I am taking another triangle. What is that? This is actually normal. Draw like this. N. So I am taking triangle ONP. What is the angle? This is the angle. This is opposite side. This is adjacent side. This is hypotenuse. This triangle. Right? It is looking like this. ONP. This is angle alpha. Right? Opposite side, adjacent side, hypotenuse. Then we require opposite side. Again, what is the angle here? Sin alpha is equal to, what is the opposite side? NP by, and hypotenuse in OP. So NP by, what is OP? A. Then NP is equal to A sin alpha. Similarly, take another triangle. What is the triangle? NSP. In NSP, what is the angle? Beta. So sin beta is equal to, what is opposite side? NP. For this, what is this triangle? What is hypotenuse? This one hypotenuse. See, it is looking like this. This is beta. This is NSP. Opposite side, this is hypotenuse. Then hypotenuse what? SP. This is NP by, what is SP? B. SP represents what? B. Then NP is equal to what? B sin beta. See, in this NP, in this NP, same, what do you do? Equate from these two. What do you write? A sin alpha is equal to B sin beta. Then this we can write sin alpha by B is equal to sin beta by A. This is equation 2. Compare 1 and 2. Sin alpha by beta is equal to sin theta by R. Sin alpha by beta is equal to sin beta by R. This we can write sin alpha by beta, or we can take first A term. So sin beta is there. So sin beta by A. Next sin alpha by B is equal to sin theta by R. This is called cosine. This is called sin R. You can write reverse also, reciprocal also. A by sin beta is equal to B by sin alpha is equal to R by sin theta. This is called Sines law. This is a helps in problems. Proof is not required. Previous proof is very, very important. To understand, I explain everything. Understand? See, very simple. Sin beta. Beta. Opposite side, for beta opposite is what? A vector. So, sin beta by A. Am I correct? Next, sin alpha by beta. Alpha. Alpha, what is there? Quite opposite, this is there. So, sin alpha by beta. Next, sin theta. R. Theta is here. For this opposite is this what? R. So, sin theta by R. Angle and opposite vector. Magnitude. Angle, opposite vector. Angle, opposite vector. Ratios. That is called, take sines, not cos. So, this is sin beta by A, sin alpha by beta, sin beta by R. This is called Sines law. It helps to solve the problems in numericals and the competitive exams.